going to do it in Spring, but like it is like just we are live.
We already live. It's okay. So hello,
So, hi everyone.
Hi Andrei. Hi,
Long time
Kurt.
no see.
Right. So yeah, I was missing these sessions. It was fun. Let's continue. So we had
Sure, and we should finish everything that we have started.
Oh, of course. As usual intention of all developers, and 100% of developers failed doing so because it's impossible. Too many directions, We had like a dozen of things started. Some of them succeeded already. One already committed. A couple are waiting to be committed, actually. A couple of waiting for review.
I think Kirk's patch about XML was committed too. Was it?
About XML, it was different patch. I mean,
that was Andre. That's not mine. Yeah,
not mine. It was
someone from years.
Right.
It was someone.
It was not from us, but it was inspired indirectly by our sessions, right? Kirk's patch related to PSQL and also related like to things, but we didn't discuss it actually. It was of these streams related to how to better print hidden echo or something like this, right? So like comments which are generated by PSQL. Okay, I'm confused already. But I feel it's right for developers to start many things, and it's okay if some of them are not committed. It's totally fine. I'm just worried about transaction timeout patch. It was the very first patch we created, and it's ready for committer. What's next?
I don't know.
What's the normal process in this case?
The good idea is to bump patch with some news, like review it ourselves and see that something can be done better, make better documentation, refactor something, and post new version and new version and new version. When you post new version, people see that you are serious about working on this, and if something will go wrong, you will fix it, and you have a better chances of committing something. But the patch is like, it's really simple, and not much can be improved there from my very first point of view. But maybe we can make something better there about transaction timeout.
Well, how do we know if it needs to be rebased by chance too? Because this is something I like, the %T for the command prompt in PSQL, that is broken now because they've made changes to the source that they took from someone else. And now my patch doesn't line up, right? So I'm going to have to rebase the %T, and that's the wrong link to the %T one in our little chat. But,
there is a, sorry for interrupting. There is a site I'm looking for, CPU Tube, it's called, and it is doing tests.
So it takes patches and brings them all to Git?
Yes, let me share.
Create a pull request or merge request like in GitLab, GitHub, right? And then if it was a GitHub or GitLab, we would see if some merge request needs updates, because like it cannot be merged anyway.
So this commit first CPU tube, I don't know where is it executing all the stuff, but when your patch is starting is fading to patch, you see here red.
Okay, yeah.
Red circles. So probably I can see when it was tested last time. It was. I don't see any date time here. Maybe a year. Oh, it was executed last time on
March 11th.
March, yeah. So it might be chances are it's outdated. If you think it makes sense, I can try try it right now. Why not?
You have admin access, or
no? I'm going to
anyone
do it
can do
like in an old-fashioned way. Just get it.
Okay, so it's manual. Okay.
Yeah, let's just download it before and or there is a white space errors. This is something we can fix, but it seems to be working. Let's try to configure it. I think it will be just fine. One day we can improve tests there, I think. I remember that there were some problems with tests of different combinations of different timeouts. The thing is, there are lock timeout, transaction timeout, and statement timeout. And you can have many of them fire at the same time. And you have to compose a proper list of what kind of timeout fired.
So it's just a matter of what message to present to the user.
And this message is really hard to test, and it's not. Initially, it was a problem for translators because you had to translate every combination of timeouts. But in later versions, I've separated string literals so that it could be translatable.
Okay, so transaction timeout works, but in general, answer to question is like you need to check manually, right? Every time you suspect it won't compile, you need to try to compile.
Well, no, a correct answer is I don't know.
Okay.
I thought that CI is enough. If you see
but CI is triggered
circle here.
Yeah, CI is triggered after some action.
I think it's triggered after any commit is interfering with your patch, but maybe I'm wrong. We can ask some CI specialists. I think I remember that Thomas Monroe was answering some questions about CPUtube recently. Maybe we can just ask
when
him.
you use Git branches, if main branches has some progress which is not compatible to your branch, you will see it in GitHub or GitLab. Like it's cannot be merged anymore, and this is static analysis. It doesn't require any compute power. I mean, a lot of compute power. It doesn't need to.
I do not even know how to get this URL. So how do I get the similar for Kirk? Like Kirk.
How did you get yours?
Someone said commit fast manager sent it to me when some of my patches was failing and HTML. So let's try Kirk. It somehow works. I don't know where is the list of all possible URLs.
It's here. Probably dynamically being handled and being looked up. So it just says HTML, but it's probably, yeah.
Maybe powered by Postgres, this search, maybe.
I'm trying just to try Andres. And I
can last name spelling, I guess.
Yeah, let me double check.
Yeah,
right.
Because that spelling doesn't look
right.
Maybe here is index. Now everything is much simpler.
Okay, I didn't know about this resource. This is interesting. I knew there is CI/CD, but I didn't know there is a list of these patches or runs. Okay.
Just wondering.
Oh, that's interesting. So you could actually Control F and search for Andres, and then click his name, probably.
Yeah, maybe.
Yes, it works.
There you go.
By the way, here, do you see it was failing?
And when returned
it was
to green.
Failing. Okay, what's the difference? Let's click few.
Oh, how like in different CI/CD systems, it's not possible to get a green step drop after some of them became red already. So, but it's interesting. It's a pipeline.
Some tests failed. I think it's just flaky test. It is sometimes it's failing, sometimes it's skip. It's not failed. Wasn't failed. What failed? Still, I think it's flaky test. It's on Windows. Exe file. So it might be very well flaky test.
Okay.
What looks amazing to me is that Postgres community is really fixing flaky tests and for the code that is committed. And I saw a lot of production environments where tests were flaky and developers simply restart again and again and again until they get this green button. And that was like horrible, but I like that Postgres tests are taken seriously, and whenever you see a red build farm, someone is fixing it, someone is working on
it. Definitely maybe about priorities, because in companies usually like maybe there's a priority to push feature faster, and tests is like considered as like, okay, we can live with failing tests sometimes. Or
you see here is that it's green if it had the recent changes, and if it's light green if it is kind of stable.
Interesting.
I don't know how it gets.
Yeah, definitely this system has like its features not very common, I think, but yeah, interesting. Okay, maybe it's time to discuss what we are going to do today, right?
Today, I want to proceed with our compression idea, which we were discussing on previous session. The thing is, I want to make FPI images compressible together. But I'm not prepared to do a compression part. I want to start with the index part. And to do index part, I want to describe how btree index is built.
Hold on one second. For those who are not like hackers yet and so on, like FPI means full page insert. It's also full page write. It's the same, right? Just
yes.
Synonym. And it's about write head log. When we first touch a page, change something. If full page writes are enabled, they are by default enabled and should be enabled in most systems. Postgres writes whole page, even if we just changed one byte, it writes whole page after checkpoint, and subsequent changes.
It's not a really Postgres feature. Many databases doing so, for example, but they're doing it in different fashions. So in MySQL, you have double write buffer, and there is a special place for doing full page writes, special log for doing full page writes. But in Postgres, we have this writes in the same write ahead log.
Yeah, and it's because we have 8 kilobyte pages, while file system might have like 4 kilobyte pages usually, and we should avoid inconsistency when writing data, right? So we need to write
not exactly about pages. Not so many file systems have atomic page write. Even if we even if they had atomic page write, their page size might be different from database. But if you have a file system with atomic page write, and the size of atomic page write is bigger than Postgres page, then you can safely disable full page images.
Like for example, on ZFS, sometimes I know people disable it.
Yes.
Right.
But essentially, ZFS will do full page writes instead of you. It will do it in a background and on abstraction layers that you don't see. Yes, but it will do many other useful things with these full page writes too. So you can not just disable.
Also, wall for ages it has a checkpointer mechanism for full page and so APIs, full page writes, right? And so I mean, we have some ability to control that we wrote exactly what we wanted and so on, right? And then when we read it, we also have protection from corruption involved in this case, right? And compression for full page
I'm
writes.
not sure that I entirely got what you are saying, but I mean, what you said is correct.
Okay. Okay, and there is also wall compression for full page writes, which probably will... Okay.
Yes, currently we are compressing each block one by one. Here you see that
independently.
We compress them independently, and what I want is to reuse knowledge of a compression from one page to better compress next page. And the main place to do so is index build, btree index build. And to start preparing for this, I want to make btree log some pages simultaneously to have this ability later to compress some pages together and exploit compression better. Maybe it will not work. It's actually just an idea. Maybe it's a bad idea, but let's try.
So the idea is that as you scan data before you compress it, LZW kind of stuff, what you get is a dynamically defined dictionary that can be used to decompress the data. The larger your data, the bigger the dictionary, the better the compression. So your game plan is, hey, we know we're going to be able to write multiple pages out while we're creating these btree indexes. Because of that, instead of limiting the internal dictionary to just the size of the wall page, which is the default behavior, if I can have it span longer because I know I'm writing multiple pages, then all of the John Smiths that were compressed in the first page, for say, as I run into them in the second page, they're already in the existing dictionary and don't need a new dictionary item to create it. And that increases, and the more pages you can write successively, the better compression you get. And so that's what you're looking at leveraging, right?
Yes, exactly.
Sounds like something that should improve data injection when we have indexes already. I mean, usually we try to, with bulk load, we try to insert and then create indexes, but sometimes we have indexes, for example, primary key, right? And
no. It will work when you create the index from scratch. It will not work when you already have an index and you're inserting many tuples into it.
So this is primarily for index creation, and the upside of doing it is index creation is already IO intensive, and it's generating a lot of write-ahead log. So if we can actually compress that write-ahead log, since we have to write all these btree entries already, and we can fix the write-ahead log and compress that a bit better, we could see a pretty good performance increase. And it's one of the ones where the more data we apply to it, the better the performance increase. Is roughly how I see that working out.
Why won't it work for to speed up index changes once it's already created?
Oh, because you're not, imagine this, just go back to the UUID example. If you insert one in the middle, you split 2 pages, maybe, or you just insert it in the middle. You're not writing multiple pages, and you may not have to write that entire page, right? Just because you have just a small change. Whereas if you're creating an index from scratch, you write everything. That's what I'm thinking.
That we can validate. Let's see how many pages do we typically have currently. Here is a code that is doing image backup, and see how many of them we are where are we doing this? Log D. So let's log it.
There you go. Good idea, right? Let's see how much we're generating before we do the change. That's a great.
If block ID is bigger than 0. Log debug. Just let's use just warning because
yes.
Block ID %d ID. Let's try build it. And wait, oh, what I did.
This was not, yeah. Looked dangerous.
My computer is still working, but if you observe the time offline, maybe I've deleted something from my system. So create table as select ID from generate series 1. Create index on X ID. Insert into X, select probably random. Let's just insert some random numbers. What happened?
Well, isn't that your message?
Yeah, that message was from some vacuuming stuff that was logging many pages together. Insert into X, select random from generate series.
But type is integer, right? Right now.
Ooh. Random. There are some cases when we have 3 blocks together. Not so many of them, but from time to time we get it. I have no idea what's happening.
Oh, that should be a tree split, right? If you split a node, isn't that exactly what happens? You have to change the one you're on. You actually have to create a new one, right? So you actually you split it into 2, and then you have to change the parent to point to the left and right. That would be 3 nodes.
Looks so. Probably we can drop index and create it with fill factor to increase chances of getting this message. Create index where it was. I think it was with fill factor 1. Would it work?
Factor without underscore. Yes.
100.
10 is minimum.
Now, when we
wanted to decrease it, not to increase fill factor, to have more splits.
Let's try it. Now we have many splits. Let's drop the index and create it with fill factor 1.
10 is minimum.
10. And now we should not have this message. Yeah, I think your hypothesis about page split is valid. We observe that we do not have these messages. Okay, so from time to time, logging of 3 simultaneous pages happens even without our interference. But let's try to improve the situation and make more blocks logged simultaneously. let's see how index is built. We have a routine to build index, which is called bt build. We have this type of routines in every access method, in gist, in gin, in hash, in bloom, and etc. And what is going on for btree? We have two stages. First one is sorting, actually. Sort scan. It will look through all the data and make sorted version of the data. This part of job is actually parallelizable. So when we are doing this heap scan, we are invoking index tuples from heap tuples. So like making a projection of index. If we have expression-based index, we are evaluating expressions, and then we are doing sorting. This sorting is parallelizable. And after the sorting of tuples is done, we are doing build from leaf level. On leaf level, we are going through each page one by one. And I think here we should see some callback or something like that. Load. We must pass callback here somewhere. Here we are building sort comparator to build index. Yes, that's not. Okay, it must be here. Build all. Seems to be slightly more complicated than I thought, but still, we have this routine which is creating a new page when we have tuples to fit somewhere. When the page is filled, we should get one more. Let's search for this btbl new page here. We have some, we should have like 2 or 3 calls to this new page. This is a prototype of a function. This is the very first page which is created. And here is, when the page is filled, we are creating new page and logging previous page. I think we can find a place where it is doing logging of a page. Somewhere here must be a call to bt build.
Right above a few
page.
lines, you have the OO page and NO page, right? The old and new page are opaque.
Yes, and here is a actual routine which is flushing a page of a tree onto disk. We see it happens when we are replacing temporary buffer with a new buffer, and also it is happening for meta page once, and also it is happening when everything is filled. Anyway, this BL write page will do actual wall logging. First, it should do wall logging of a page, and only after wall logging is done, it will do actual write on a disk, SMGR write. So here we must postpone the actual work to do not log a new page, but log new pages. Here you see S. The difference is that log new page takes 1 page, while log new pages take many pages and number of pages. I think it will emit just 1 record for as many pages as it can. And we can collect up to XLR max block ID pages, basically 32 pages. here we have a state of a building index, and we should postpone actually writing this page. Meanwhile, we have to keep in mind that we are passed a temporary buffer. Like page here is a temporary buffer. We can see that it is freed somewhere. I think, yes, here is a emptying of a page. So when someone had called BL write page, we effectively own this region of memory. We own this 8 kilobytes of memory and have to make sure it will be freed once. What I propose to do is to make a buffer in a state. Actually, we are relying here on the fact that addresses will be made sequentially. Do we tell anyone current current page number? No one is using this information. So when someone is passing us page, they are also passing us number of block. So this is a addressing file where they want to see this page. So we have all we need here. Let's make an array in this structure. We have page I don't know how to call it, pages that we have to flush later. Deferred pages, XLR, max block ID, and block numbers, deferred block, no. And also we want a number of deferred pages. We have to make sure this is 0. So whenever someone is using this structure, they have to zero out deferred pages. 2. Okay, so we have a place to store our temporary pages. What? Sorry.
Before we propagate this deferred, we should write double R and single F. This is my contribution to it. I mean, it's
okay.
Yeah.
Like this.
Yes. Good catch. And then fix the initializer.
I need the ID to help me. Different pages. Great. It should work now. Okay. That's the place where we can postpone the stuff. Also, we need to change prototype slightly. Like sometimes we have to force flushing. What's the place? It is inside regular build, so we don't have to force here. This is the end, so we have to force here end of a tree build, and also meta page we have to force meta page too. Okay, so we have all we want here. If not force, and we still can postpone something. Deferred page is less than max XLR max block ID.
By the way, we have a comment from chat that it should be XLR max block ID +1 because it's 0 indexed, but 33 sounds not good compared to 32. I mean, just not even number, but it starts from 0, right?
Yeah, I know. We will get a sick fault and fix it later. I just don't know.
Okay.
Okay, so if we can postpone, and this is great that someone is actually writing something to the chat. Yes. Thank you very much.
Thank you. Yeah.
If not force, and we can postpone what we are doing, we are postponing different block numbers. Different block numbers. Block no, and different pages. Different pages. Is page, and also increase it. I think we should do something like that. I think someone from chat is absolutely right. Let's just make here +1. It will make our code much easier to read if we allocate slightly more than we need. Then we can here just write return. I don't know. I don't get why we have this red line here. I believe that Visual Studio Code just do not understand what we are doing. That's totally fine. And now we have to do a loop.
You want to keep that -1 in comparison, or
I have no idea. Okay. We should review it later.
Okay.
What? No, what I'm doing. No, that's totally fine, but not here. Let's do it there. Here if we have to use wall, we can log new pages. And what's the difference? Is that something here somewhere? Num pages after number of fork. Num pages after number of fork. And instead of block numbers, we should use these block numbers. And these pages. And all the other stuff we have to do in a one giant loop. I hate that Visual Studio is breaking PG indent. Okay, so now we have a block. What was called the actual argument? I. And page is now pages I. And when we are done here, we should reset our deferred pages. I believe that's it. That's all we have to change. Unless someone is commenting this in the chat. Let's try.
Yeah, there are comments, but I don't see how about intent. If you can look at comments, it would be great. Yeah, probably there's some page.
Okay, I will just finish this stuff and get back to comments.
Array type is not assignable. Maybe this comment maybe it should be int actually, not page array.
It's line 263. 263. I think it's somewhere there. Pages. Page count.
Same variable twice. Don't forget the initializer to force it to 0.
How do I find it now?
It should be an open file.
Yeah, here we go. Let's try to compile it again. I've done another bug here. Different page count. One warning and here is a conversion from pointer to integer. It's a good catch of a compiler. So it seems to be working. Let's make a check. It will fail for us because we have this login. It's not even here. Here we can comment this login to run tests. Compile again and make check. Did we break everything entirely? Or didn't we? Yeah, the database seemed to be up and running. I hope that we didn't break anything.
Are you saying the database is working? You didn't break it?
That's strange, but yes. Let's restore our comments, our login, and reinstall the database. And restart it. And now when we create index, we should see you see it. We now emit records of 31 pages at once. That's what we was going to achieve today. So if you have some ideas what to test else, I feel that it's kind of a success.
The first question, why did we do it? Because of performance, right? We
yes,
could compare.
We are going to reduce amount of wall written when you are doing index creation. But
okay, so we need to test for it. We need to test to compare before change, after change, and we could measure.
But it's only half of problem, half of a solution, half of the idea, because we also have to make a compression.
Span the blocks.
Yes, and I'm not prepared to do it today because I cannot configure with this standard. I tried yesterday to prepare. So if I say with this standard on my machine, I get the error. If I could fix this today, we would finish it, but seems like we'll have to finish it on next session because I just can't build with the compression libraries. And the only working compression libraries that I have now is LZ4, PGLZ, and it is not suitable for compressing together many FPIs because it cannot continue compression. It's working only on some range of bytes.
So one test we could do is, could we try that fill factor trick and see the 3 block split and see just how the update of the index is impacted by our recent change? So right now you did it on create index and it showed that it saved 32 pages worth. But remember when we just did the update, it generated 3 pages that were going to be updated. I'm curious to see how, it captures when we just insert some extra records into the index. We should see it.
But we didn't change anything in actual index. We only changed how it is logged. Now we do not do log for each individual page, but do log for a bunch of pages.
So we only impacted the build code that's building a raw index.
Yes,
we shouldn't have impacted any code for just updating an index.
Exactly. We get exactly the same indexes, but they are logged in slightly different way. And by the way, the login is still compatible with another version. So we are just replaying full page images of this these pages. Maybe it's a little tricky to understand. Yes, it's FPIs, but when you are doing index build, you are doing it unlogged, and when it's done, you are emitting FPIs for all the pages of newly built index.
Right. Okay, so now that I see that, the only way we can really test this technically is if we actually cause the wall logs to be played back and actually get, right, but that would be the proper way to test that we created the wall files correctly, is that we would actually
it's fairly easy to test. We have replication tests.
There you go.
Just let's find it. Replication. I think we should have a test for this somewhere. Just do not remember where exactly it is.
We have related question related to tests from chat. Does this pass check world with TAP tests? Because I'm kind of worried that the buffered pages are released before the wall is logged, thus resulting in read after free for wall record data. So
buffer pages are not used for index build. So you can see that there is no buffer manager calls. We are using just temporary allocations, PL new page, and it's just p allocking new page in current memory context. It's not in buffer manager because it doesn't need to be there. It's used only by our backend. It's not shared with anyone, so it's not in shared buffers. But someone who asked this is really
you should check the chat. Like there are more comments.
We should ask someone who
I would like you to check the chat directly if you want.
How to do it?
I'm sending the link. sending the link.
So there is it's on YouTube.
Yeah, there is the link here. I sent it in Telegram and in Zoom.
I don't see a chat there. I don't see a chat there. Sorry. Maybe I can see a Zoom chat.
Zoom and
Give it a few seconds. The chat just showed up for me. So I see the chat now, but it took a few seconds. I paused the video playback and it's on the right-hand side.
I think Andrei says that he cannot find the Zoom chat where I sent the link, but I also sent it in Telegram.
I found the Zoom chat. Okay. I'm looking translation on YouTube. I see myself there doing some writing and P3 in pages, but I don't see a chat. Sorry.
That's weird.
I can
on the right-hand side of your screen. Do you have the hide chat feature? You can hit the ... right below, and then usually turn on the chat. Yeah. So ... there it is. There's your chat on the right-hand side. Good.
It's not there.
And
it doesn't pop up. I mean, there is chat, but it's empty. Something is blocking.
Mine was empty for like 30 seconds, and then it showed up.
Okay.
Here, let's see if me sending something, maybe that'll update your chat.
You sent something answering to the question. What are you guys coding? Something like, well, yeah, we do coding.
That wasn't the intention. Yes.
Yeah. For those who just joined, we started to code something interesting to improve the index build time and how much wall is generated when you create a new btree or index. An index also will benefit from this optimization, right? So better compression.
Someone who asked in chat about shared buffers, can we ask him here if they can help me with configuration to have the standard?
But it's in macOS, right? This is something.
Yes.
Yeah. So if you could try on Linux, maybe it would work.
Configure that standard here. Something's not working for the standard. Anyway, any advices would be welcome. If you have some ideas, drop them into the chat, and I will find the way to see the chat anyway. But let's run some tests. Sources, tests, replication, recovery. Check. And let's look what will be tested there in recovery. Here, tests, recovery. We have some top tests for streaming replication, for archiving. So exactly the thing that we want, but what I want to see here is, do we have a test for index creation? Create index. We don't actually. Do we have here create table with primary key? We don't. They all lack primary key. Maybe some other logical replication for sure have to have a primary key. I am certainly, but no. No primary keys. So I have a hypothesis. If I break index creation, no, tests will fail because I cannot create a cluster without having index built. So actually, what I see here is the lack of coverage of wall of index creation. Maybe I'm wrong. I see in the chat that we have some suggestions for me to run. Brew install.
Yeah.
I'm sure that I was writing this before, but maybe this one will help.
And the answer from someone from chat that sadly never worked with ZSTD in Postgres and cannot help with that. So, but let's see.
In previously, I was I had a build with ICU2, and it worked fine for me.
So we have
But
everything
now
installed
something
here,
changed.
and up to date, but still not compiling, right? Not configuring. You should just use Linux, maybe.
Yeah, good idea. Then I will have to install Zoom too.
No,
Linux.
remotely at least. Like, I mean, you could just take a VM somewhere and try there. Maybe
makes
it will
sense.
work easier.
And actually, Nikolai, you could say like just use Gitpod and
I
cut there.
already lost my hope in this, unfortunately.
You
I will
see, the
probably
configuration seemed to be successful. It's not failing, at least for now.
so we did something
Maybe
good, right? Yeah.
we have like 15 minutes more, so maybe we will finish the overall idea of compression, and next time we'll just test it.
So the other question that went through my mind as a reverse test is if we created a temporary index, technically that's considered unlogged. So would that not create any wall table entries?
What is temporary index?
If you create an index on a temporary table, right, then it's unlogged by definition. And then if it's unlogged, I don't think it creates any wall entries.
Yes, it's unlogged.
Right. So I'm curious if we created a temporary index that way,
So.
if we see it not log the warning messages that you programmed in there. It's an inverted test, right?
Right.
Have connection issues, I guess, on Andrei's side.
Yeah, he froze up for a second. He installed Z standard and now his internet doesn't work.
Right.
He broke his operating system, Z compression.
It's sad we lost Andrei, I guess. But based on the last line he wrote, he understood you, obviously.
He was going to test that.
Yeah.
Oh, Andrei, I heard you.
Maybe it's a sign to wrap up, actually. But it's interesting. Like
tests and these tests. Let's see what is done.
Oop, we lost him. Okay, let's maybe wait a minute if Andrei returns. Okay, Andrei returns. Great.
Oh, do you hear me?
Welcome back.
Yes. You fell off.
Some hiccup. I think it was like tests made my MacBook just too hot for this stuff. It's kind of summer, and I have air which have no cooling built in.
Okay, that makes sense. So
you want to share your screen again?
Yeah. It's still compiling. Tests failed for some reason, and I don't know why.
But packaging issue we solved, right? On macOS, on your macOS.
Yes, indeed. That stuff with that brew stuff helped.
Okay, it was straightforward solution, but you know who we should thank?
I still do not have a chat.
Chat is right first part of the solution. So the chat word. So I made a screenshot. Then on macOS now you can copy paste text right from screenshots from images. Right, it's good cool feature working on macOS and iOS and so on. Then I went to ChatGPT version GPT-4 and asked what to do, and it says just install these things, and it helped.
Cool.
Obviously, right? Well, it works to save time sometimes, right? So,
guys, I just have some problem with my laptop, and
yeah, when you share screen, it consumes a lot of CPU. Probably should just wrap up at this point. And
it's not about Zoom actually. It's about replication tests, which just hit up CPU, and now everything is not working.
Another reason to use a remote VM somewhere. Tmax or something. Yeah.
Okay, so maybe let's stop here for today and continue with compression next time.
Yeah, it was fun. Thank you. I hope we will continue this interesting research. I'm very curious to see performance comparison at some point.
Yeah, and maybe in meantime you will like think about how we can test
measure
amount of wall. Yes, measure amount of wall which is generated when we are doing create index.
Well, obvious idea to check LSN, current LSN, because it measures the progress, how much LSN we generate. And also a different idea, we could check, if it was Linux, we would check proc IO numbers to understand how much actual disk writes happened. Another idea.
Yes. Could we review what gets dumped into the wall folder and from a replication standpoint?
Wall
right?
dump, yes.
Wall
dump also. Yeah.
Just take a look at wall dump with and without that feature for the same create structure.
What I would like to just to see one number, how many wall file was generated for create index, and I don't know how to get this number.
Oh, what folder is the wall stuff stored in?
PG wall.
PG wall.
PG wall, yes. I think it's
under data PG wall.
Yes.
And then you should see a bunch of individual file names.
Right.
Yes, they will be here. But the difference might be less than 16 megabytes.
That's why we can use PG wall and just check the content and compare it. Maybe grep, maybe wc-l something and compare some number of lines.
Well, or what we do is we create the number of records required to exceed 16 megabytes of wall in right? And then with and without compression, we should actually see at least less wall, but then peeking inside the wall files and seeing what's actually written there. That's interesting as well.
There's new fancy feature to look into wall content writing from SQL. PG wall dump was made available. I'd never tried it. I just know from release notes it's possible. So we could try that.
PG wall dump in other country, something like that?
So, I don't remember. So if you have modern version of Postgres, obviously you have, because it's from main branch, master branch, right? So it should be possible to...
better one I have. That's what I have.
So there is a PG wall LSN diff, wall file name, and wall replay stuff as functions.
Okay, so let's code.
But we can play with it next time.
Yeah. Here is all the diffs that we generated. Then in white spaces. Okay, we'll fix it next time. And some btree stuff. So let's stop for now. Thank you, guys.
Okay. Thank you so much. It was interesting. I can't wait to see the result as well. And we need two numbers. This sounds like a manager position, you know, like final numbers to compare.
Now we need to measure, right? Awesome.
Yeah.
Okay. Thank you.
Thanks, everybody.
Until next time, those who watched this, this is proper time to like, share with your colleagues, and those who are interested in Postgres hacking a little bit, and comment please if you have some ideas or feedback. Thank you. Bye-bye.